Let us start our last topic, rate measure. There is nothing to explain. In its name, the meaning is there, rate measure. So everywhere, rate of change of the word is there, then we have to take the differentiation. Okay, so rate measure examples are there. Rate measure examples means related to velocity, related to rate of change of volume, rate of change of area, and so many examples are there. Rate of change of displacement is nothing but velocity, rate of change of velocity is nothing but acceleration, and so on. So let us consider the examples. The first one, write down, a particle moves along the curve. A particle moves along the curve. Along the curve. The curve is given 6y is equal to x cube plus 2. Remember guys, this question is wrong printed in our textbook. There is a mistake, printing mistake. So let us clear this. 6y is equal to x cube plus 2. Particle is moving along the curve. 6y is equal to x cube plus 2. Find the points on the curve at which, find points on the curve, points on the curve at which y coordinate changes, y coordinate at which the y coordinate is changing 8 times, y coordinate is changing 8 times as fast as that of x coordinate, Okay, consider this example. Read it carefully. A particle moves along the curve 6y is equal to x cube plus 2. 6y is equal to x cube plus 2 is the curve. We have to find the points on the curve. Means we just have to find the coordinates of that point at which the y coordinate is changing 8 times as fast as that of x coordinate. Now remember, particle moves means we have to consider here the movement with respect to time, right? So y coordinate changes, x coordinate changes. How the coordinate changes with respect to what the change is there? Here it is displacement. So we have to consider the change with respect to time. Remember, we have to consider this change with respect to time. Sometimes you may take this derivative with respect to x, but consider this change with respect to time. So 6y is equal to x cube plus 2 is given curve, means given equation for us. Y coordinate is changing 8 times as fast as x coordinate. What is the meaning of this statement? Y coordinate is changing 8 times as fast as that of x coordinate. That is, and what? Y coordinate changes means rate of change of y with respect to time t, dy by dt is equal to rate of change of x with respect to time dt into 8. Y coordinate changes 8 times as fast as that of x coordinate. Okay, this is the given part. These two things are given in this equation. Now I will consider the function, this one. This is suppose 2. Now differentiate 1 with respect to time. Therefore, yes, here it will be 6 into dy by dx is equal to, yes, here it will be x cube means 3 times x square, but we are differentiating this with respect to time t. So 3x square into derivative of x with respect to time t. So dx by dt, and the second term is constant, so its derivative will be 0. So 6 dy by dx is equal to 3 times x square dx by dt. Reduce this by 3 or take this 6 to the right hand side, you will get, therefore dy by dx is equal to dy by dx is equal to, yes, what will you get here? 6 is divided, so 3 upon 6 x square into dx by dt. This is equal to 1 by 2 times x square into dx by dt. This dx by dt, using this one, it is nothing but 1 by 8 times dy by dt. This 8 will divided here, so dx by dt is equal to what? 1 by 8 times dy by dt. So this is nothing but, you can write this as 1 by 8 times dy by dt. dy by dt. Here is also dy by dt. Now look at both the sides. So here you will get, therefore dy by dt will get cancelled. There remains, here this is cancelled, means there remains 1 only, is equal to 1 by 2 into 1 by 8, that is 1 by 16 into x square. Therefore we have to find this x. So x square is equal to 16 will multiply is equal to 16, and since x square is equal to 16, I will get two values of x. Taking square root on both sides, it will be plus or minus 4. Yes, x is equal to plus or minus 4. Now put this x is equal to plus 4 and x is equal to minus 4 here in this equation 1, so that you can have the value of y. We have to find x, y coordinates of that point. Okay, so put x is equal to 1. Therefore equation 1 becomes means equation 1 will give you the value of y. 6 into y is equal to x cube, that is 4 cube plus 4 cube I will consider, plus 2, and second 6y is equal to minus 4 cube plus 2. Therefore here y is equal to, means for x is equal to 4, y is equal to 4 cube. 4 4s are 16, 16 4s are 64, 64 plus 2, 66, 66 upon this 6, 66 upon this 6, that is equals to 11. And here it will be y is equal to, again minus 4 cube means minus 64, minus 64 plus 2 means minus 62 divided by this 6, that is minus 62 divided by this 6. You can reduce this by 2, it will be minus 31 upon 3. So what are the coordinates? Find points on the curve. So what are those points? Therefore required points are yes, first point, x coordinate is plus 4, at that time y coordinate is 11, and x coordinate is minus 4, at that time your y coordinate is minus 31 upon 3. Okay, got this? Y coordinate is changing 8 times as fast as that of x coordinate. So dy by dx is equal to 8 times dx by dt. This is the curve given, differentiated with respect to x. We get the relation in dy by dx and dx by dt. So dy by dt and dx by dt. Using equation 2, we put the value of dx by dt. You may put the value of dy by dx as it is. It is solved. We get x square is equal to 16, and hence x is equal to plus or minus 4. And then we solve this by substituting this value of x in equation 1. We get y is equal to. Okay, so these are the rate measure examples like this. We will consider the next example. This is the first one. What is our answer? The first point is 4, 11, and second point is minus 4, minus 31 by 3. Okay. Now let us consider next example. Second example we will consider. Write down, the surface area of a spherical balloon is increasing. The surface area of a spherical balloon is increasing. Balloon is spherical I will write only that. Spherical balloon. This is an example from your textbook. Ninth example is there. Spherical balloon is increasing at the rate of 2 centimeters square per second. Surface area increasing at the rate of 2 centimeters square per second. Surface area is increasing at the rate of 2 centimeters square per second. So at which rate is the volume of the balloon increasing? At which rate the volume of the balloon is increasing? At which rate volume increases when the radius is 6 centimeter. When the radius is 6 centimeter. Radius is 6 centimeter. Okay, this is the question. Spherical balloon is there. Its surface area is increasing at the rate of 2 centimeters square per second. One more thing is given, that radius of the balloon is 6 centimeter, and when radius is 6 centimeter, we have to find the rate of change of volume of that spherical balloon. So first of all, you must know what are the formulae for surface area and volume of the balloon. For surface area and volume of the balloon. Balloon is having spherical in shape. So for a sphere, what is the area of the sphere? Let us consider, first of all, we will consider radius r of that balloon. Let r denotes radius of the balloon. Radius of the balloon. Therefore, what is area? Surface area, I will denote it by S. S is equal to, what is surface area of the balloon? It is 4 pi r square. And what is volume? V. V is the volume of the balloon. V is equal to 4 by 3 pi r cube. Formula correct? Are they correct? S is equal to this one and V is equal to this one. 4 by 3 pi r cube is the volume and 4 pi r square is the surface area. For the balloon, we will note here spherical balloon. Okay. Now, what will be derivative of this term? Differentiate S with respect to time. Look here. Rate of change of surface area is centimeter square per second. Per second means with respect to time. So differentiating this with respect to time, I will get ds by dt is equal to 4 pi is constant. Derivative of r square is 2r, and since we are differentiating this with respect to time, so dr by dt. Therefore, this value is given to me. What is this value? This value is 2 centimeters square per second. Right? So, the given thing, this one is given 2 is equal to 4 into 2, 8 pi r into dr by dt. So, using this one, I can find the value of dr by dt. Dr by dt is equal to 2 upon 8 pi r, that is 1 by 4 pi r. This is value of derivative of r with respect to time. Now consider this volume, derivative of v with respect to time. Now differentiate v with respect to time t. V with respect to time t. Okay, because we have to find rate of change of volume, at what rate the volume is increasing. Okay, so differentiating this v with respect to time, that is dv by dt, that is what I have to find. dv by dt, that is what I have to find. dv by dt is equal to 4 by 3 pi constant. 4 by 3 pi, it is constant. Derivative of r cube is 3r square into dr by dt. Remember, we are differentiating this with respect to time. So r is also variable. I have to differentiate this with respect to time. This is equal to, remember, what are the variable terms, all those should be differentiated with respect to that variable time t. Okay, so here s, v, r, these are variable things, so I should differentiate them with respect to time, differentiate each variable with respect to time here. So here I will get 4 by 3 into 3 will get cancelled, 4 pi r square into dr by dt is obtained. What is value of dr by dt? Is nothing but 1 upon 4 pi r. So this is equal to 4 pi r will get cancelled. Look here, 4 pi r will get cancelled, there remains r. So dv by dt is equal to this one, and what is value of r? R is given. R is given at when the radius is equal to 6 centimeter. So put this value, this r is equal to 6. So what is rate of change of volume? That is, at which rate the volume is increasing at the rate 6. Now since it is volume, what should be the unit? Centimeter cube per second. So your final answer, the rate at which volume is increasing when radius is 6 centimeter is 6 centimeter cube per second. It is 6 centimeter cube per second. Let us again revise this. What are the given things in this example? The rate of change of area is given. Rate of change of area is given. It is 2 centimeter square per second. Then next one is what? Yes, radius is given. Radius is 6 centimeter. And what we have to find? We have to find rate of increase of volume when radius is equal to 6 centimeter. So these are the things. Now we will consider surface area and volume of the sphere, because balloon has the shape of sphere. So these two formulae considered. First of all, differentiate this with respect to time. Rate of change of area, rate of change of radius, rate of change of volume, they are with respect to time. So this one is considered. Substitute this ds by dt, which is already given 2 centimeter square per second. We obtained it using that one, dr by dt. After obtaining dr by dt, we consider derivative of v with respect to time. Then put the values of dr by dt, which is obtained already. Then after that we got here r only. Now at what value we have to find rate of change of volume? We have to find the rate of change of volume when radius is 6. So I put the value of r, and this is nothing but rate of increase of volume. So what is your final answer? Your final answer must be the rate at which the volume is increasing. So how to write your answer? The rate at which volume is increasing. The rate at which the volume is increasing. The rate of volume at which increasing when radius is 6 centimeter is nothing but 6 centimeter cube per second. You may write it as answer, rate of increase of volume is 6 centimeter cube per second when radius is given, that radius is 6 centimeter. This will be your final answer. Okay, so these are the two examples.